Approximate polynomial solutions, Desmos advanced task number 23. Okay, this is really spectacular here. Now, we're going to learn basically some sort of advanced algebra. If you look at the equation that's it's in box number 46 there, the one that has a little warning on it, this is a cubic equation, which of course you have not learned how to solve. You've learned how to solve up to like a quadratic equation by either factoring or using the quadratic formula. And next year in Algebra 2, you'll learn some techniques to figure out how to solve cubics. But in the meantime, we can use the graph to help us solve that equation. And there's a couple of ways to do it. And beyond just being able to use this on anything on the PSAT or SAT, this is actually one of the skills that the AP Calculus test requires of students as well. There are 4 tasks that they have to do, and one of them is being able to solve, this is a polynomial equation here, by just using a graphing calculator, which Desmos definitely is. Okay, now if you were to go up here and you were to delete the quotation marks like we did in the previous one, it's going to try to graph this, I think, if I turn this thing on, as a vertical line. Actually, it shouldn't be a vertical line at all. It should only be one dot. It should only be a point that is on the x-axis. And in this case, it won't even tell me what that dot is. Like, I'm trying to tap on it right here, but it's doing nothing. You use your little mouse or whatever, you can't get that exact value. And I don't want you to just try to like zoom in and estimate it. We can do a better job of that. But what's happening here is I believe that the solution here is irrational, and so Desmos is just approximating it, and I unfortunately can't interact with it, but there's a way around it, and I'm going to show you 2 different ways. So here is the first way. I'm going to turn this graph off, and I'm going to do this as a system of equations. And the system of equations is basically going to be the left side and the right side of the equation, formatted as 2 separate equations, and we're going to find where they intersect. Watch. So on this next line, I'm going to type in y is equal to, now it's the left side of the original equation, which is x cubed minus x. So x to the 3rd power, arrow out of that guy, and then minus x. Okay, this is not what we want. We're not looking at the x-axis at all for where the solutions are. This is just the left side of the equation formatted as a function, okay? And now on box number 48, whenever I go down here, I'm going to type the right side of the equation in as a function, which is going to be y is equal to 1. So y is equal to 1. It's going to think that this is a slider. So whenever I click off this box, it's going to turn into a slider, but I'm going to keep it like that. And so what I'm doing is I'm solving the system of equations by looking at where these graphs intersect each other. And it is this value here. Whenever I tap on the point of intersection, notice that it's now interactive. I can see it's about 1.3-ish. It's some weird irrational number, and there's a limit to the number of decimal numbers that Desmos is going to report for me. So the reason why this works is because, like I said, if I look at the 2 things that I typed in on 47 and 48, the x cubed minus x, we are seeing where it's equal to, box number 48, 1, by seeing where these 2 graphs cross each other, okay? And then I can pull this guy right into my expression list, and let me just move this where it is helpful, okay? So this is one way to do it. However, it's not always the preferred way to do it, especially when you have a TI calculator. And the reason why is because this one was really nice, as in it was on the default calculator screen, I can see the point intersection very easily. But sometimes when you're solving equations, it is not on the default screen, and you have to scroll, 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 zoom, 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 zoom in or zoom out in order to find that point intersection. So we can kind of simplify this a bit and only have to look in the same place every single time. And this is the way that we do it. So let me come over here and actually be able to write on the screen. And it looks like this. I have x cubed minus x is equal to 1. What I'm going to do is I'm going to make this thing equal to 0 by subtracting over the 1. X cubed minus x minus 1 is equal to 0. Isn't that the first thing that you do with quadratic equations when you solve them? Guess what? That's what you do for all polynomial equations, is that you make the thing equal to 0. But again, if I type this into Desmos right now, you're going to see it's not going to be interactive. So if I type this into this next box, x cubed, x, yeah, cubed, and then minus x, and then minus 1 equals 0, I just get that vertical line. And notice that that vertical line does go through the point of intersection that I found because it is the same exact solution. But down here on the x-axis, you can see I can't interact with it. I can't get a more accurate picture of what those decimal numbers are, okay? So I run into that same exact problem that I had with just looking at box number 46. As a matter of fact, if I turn these guys off and I turn 46 back on, you're going to see the exact same graph pop up. That I have no way of finding that x value. Okay, but there's a way to fix this. The way to fix this is to turn it into a function. And to turn it into a function, where there's a 0 there, you're going to make it a y. And now it's a function that it can graph. This is going to be a cubic equation, which looks sort of like this. And what you're doing is you're thinking of, okay, that thing is not supposed to be equal to y. It's supposed to be equal to 0, right? And you can see I just wrote it right on top of it. And so what you're thinking of is, where on my graph would y be equal to 0? And very specifically, that is always on the x-axis. And so why this is actually the preferred method is that all you have to do when you're looking for the solution is find where it hits the x-axis instead of finding some random point in one of the other quadrants where I may have to just shift my graph around. On Desmos, it's not that big of a deal, but on the TI calculator, it definitely is. So let me show you this as an alternative method on Desmos. So I'm going to go and turn, I'll use this one right here. I'll just delete out this 0 and put a y there. Okay, and now it turned it into a graph for me. And when it turned it into a graph, I need to turn this guy off. There we go. There we go. And notice that it has the exact same, whenever I click this, it has the exact same point to intersection here. But notice that what I had to do is just find where it hits the x-axis. So if I had this weird graph, all I have to do is go left and right until I see where my graph hits the x-axis. And that's sometimes a simpler thing to do, less complicated than having to search for some random point in the coordinate plane, okay?